Now in this lesson we're looking at differentiation involving exponentials and logs. A couple of standard results firstly. If we have y equals log of x, then dy dx equals 1 over x. If we have y equals e to the x, then dy dx is also e to the x. And that can be expanded somewhat. If y equals e to the ax, then its derivative, dy dx, equals to a multiplied by e to the ax. Very good. So those are three different results. We'll just write them down in a box here, and we'll keep them highlighted to look at our first few examples. We're asked to differentiate, firstly, y equals e to the power of 3x. Well, simply what we do, dy dx equals, we look at that power, 3x, and we find the derivative. So the derivative of 3x is 3, so we write the 3 out the front, and then we write the exponential as we see it, e to the power of 3x. Question 2. Y equals log of 5x plus 1. Well, because it's a log, it's involving, okay, the idea is the 1 on x, the derivative of log x is 1 on x, so it's going to be the 5x plus 1, it's going to be on the bottom. We write dy dx equals to the 5x plus 1 on the bottom, then we look inside the brackets and we think, what's the derivative of that? Well, the derivative of 5x plus 1 is 5, and we put the 5 on the top. Very good. Now our next question, the derivative of y equals x log x. Well, x log x is in fact a product. X is being multiplied by log x. So because what we'll do, we'll let u equal the x, and then we'll let v equal log x. Notice I've left a little bit of room there because we're going to do the inside and outside routine. So firstly, if u equals x, then u dash equals 1. If v equals log x, then v dash, the derivative, equals 1 on x. So we match up the insides with the outsides, and because it's the product, it's going to be inside plus outside. So dy dx equals, firstly the inside, 1 times log x, and we add the outside. So we add x times 1 on x, and that simplifies to be log x plus 1, where simply the x times the 1 on x simplifies to be positive 1. Terrific. Alright, now we'll just wipe the right hand side there, wipe that clean, because we'll need to look at this next example here, our final example. Y equals e to the 2x over 2x plus 1. Well, in this case we've got a division, so we're going to use the quotient rule. So we look at the top, e to the 2x, we let u equal that, let v equal 2x plus 1, and we need to differentiate. So if u equals e to the 2x, then u dash equals 2 at the front of e to the 2x. If v equals 2x plus 1, we'll find the derivative, v dash simply equals 2. So there's our inside, there's our outside, it's the quotient rule. So dy dx equals, firstly the inside, if we multiply those two together, that's what we get. Then we're going to subtract the outside. So we minus 2 times e to the 2x. And that whole thing, because it's the quotient rule, the whole thing's over the bottom squared. Excellent. Now at this stage we can expand the brackets. So if we expand those brackets, we get 4x times e to the 2x plus 2e to the 2x. And on the end there, of course, it's got minus 2e to the 2x. It's all over 2x plus 1 squared. Now we look to collect like terms if we can. Notice we have 2e to the 2x, then we subtract 2e to the 2x. So effectively they cancel each other out. So we finally get then our final answer, our derivative, equals 4x e to the 2x on top, all over 2x plus 1 squared. Excellent. Well, that concludes the lesson on exponentials and logs, the differentiation of them.